Friends, hello, my name is Eric. Today is Saturday, March 15th, 2025. It is 16:01 Eastern Standard Time, and today we are going to actually continue a project, which is a bit unusual here. First things first, though, I noticed in the last stream and recording that there were some synchronization issues between the video and the audio, and I think that was a one-time problem. I don't think I'm going to continue having that problem, though I think it's a little bit loud, and I might need to turn this down here. Just a couple clicks. Okay, so yes, I think those were perhaps due to the jack input client that I showed in the open source audio video I did a couple weeks ago. I'm wondering if maybe having all of this running together caused some synchronization issues between the audio and the video. I did a test recording before this stream today, and it looked like those were resolved, so I went ahead and continued with the jack input client because it's more dynamic. There are more things I can do with it. But if I see that those issues persist, then I'll switch back to the ALSA client, and that should fix it as well. It wouldn't be particularly hard for me to go into the video and shift the audio a bit so that it is correct. But kind of the point of me doing this in a live stream setting is so that I don't have to do much editing. I can kind of just turn it on and go. So I can do that, but I generally don't want to. So let's move on. Trying to fix those audio issues. Yes, and last time I was showing you getting my NVIDIA GPUs working on Kubernetes, and where I left off, we were trying to get LocalAI running, and I have done that. Before that, though, I did a few experiments. If you remember from last week, I was talking about how I originally had a NVIDIA RTX A6000. It is on my desk back there. You might be able to see it. So I had that in my server, and that is a very powerful GPU with 48 gigabytes of VRAM. Unfortunately, I was not able to get it working. If we go back to my Git server over here, we'll come back to this page in just a second. Let's see, I'll make this bigger for you. And let's see. Software infrastructure issues, and I guess that didn't happen. This one, I need to reopen this one. So the original issue was that on the host system, I would get this error in dmessage of RM init adapter failed when I would try to run NVIDIA SMI, and I would not see that the A6000 was available on the host system. I tried for quite a long time to get this working and tried a number of different things, hoping that a driver update would potentially fix this, or different power supplies, or some other internal configuration, and eventually I decided to swap it out with this Tesla T4, as I was showing last week. And the Tesla T4 works just fine. I believe the ticket is closed, or maybe, yeah, this one. So this one was a lot quicker. I just ordered the T4, tried it out, and it kind of just worked. And I can show you it working today. We have LocalAI working. That being said, what worked here specifically was that I did GPU pass-through on this GPU, the T4. And that's what I showed you last week. But I never actually tried doing GPU pass-through on the A6000. I got to the part of seeing on the host system that we had RM init adapter failed, and I never tried to get it to work using VFIO and GPU pass-through. After getting the T4 working, though, I was curious and decided to go ahead and give it a try because you see, the issue here, this RM init adapter failed, was happening on the PowerEdge server, not the virtual machine guest. And since the PowerEdge server is being told, don't load any NVIDIA drivers, don't load any drivers, just VFIO for this GPU, pass it on to the guest, the guest was actually able to use the A6000. So that's a much more powerful GPU. And it would probably be better for running AI tasks to use it. I can run much bigger, more powerful models. Unfortunately, even though it was actually working, it was like standing next to a jet airplane taking off. My server became ear-splittingly loud, and that was untenable. I searched through the iDRAC settings to see if I could turn down the fans, and they were all just at 80% no matter what I did, and that was, for an apartment, untenable. So I have taken that back out, but I'm not sure what to do with it. My original plan was to swap it for multiple T4s, but now knowing that I can get it to work in this system, I'm tempted to hold on to it even longer and see what happens there. But anyway, for today, we will continue using just the T4. What I would be able to do in the future potentially is run local AI models on the A6000 and then have like a Jupyter Hub notebook for doing AI modeling or whatever I want to do there. And the T4 being a smaller card could be appropriate for that. But again, I'm just going to use the T4 today and probably for the near future while I get things set up, and I'll probably have to decide what to do about this A6000 as I go. Okay, so let's talk about local AI on Kubernetes, and I'm going to take a timestamp. Together, but that's okay. We'll just see. The new one, I guess. This is going to be a bit interesting. Usually in OBS, I'll start a stream, start a recording, and I accidentally hit the wrong key on my keyboard and stop the recording. So we'll see what happens there. We might have lost something, but shouldn't be too bad. Anyway, local AI on Kubernetes. I am going to show you the Ansible task that I used to deploy this, so we can see the configuration that I'm using first. From the other streams that I've done, it should be clear at this point how Ansible is generally used. This may still be too small for viewing, so I'll make it even bigger. This is the default repository for the Helm chart for local AI. So there's a task here to add that repository and then update our repository so that it is available. And then for deploying, we only have a few values that we need to set. First of all, I'm setting the service type to load balancer. As far as I have seen so far, local AI does not have an authentication system, so I don't want this to be exposed to the internet. Usually in my Kubernetes services, I am adding ingress rules and making this will be a cluster IP service, and the ingress rules will handle traffic from the internet using a public domain to access this service. And I will also use that same domain. In fact, I'm doing that right here with GitT. GitT is hosted on my Kubernetes cluster. It's using those ingress rules for that domain, etc. But again, local AI, we can't authenticate, at least not yet. So I have set the service type to load balancer. That way I can access it by a IP address on my local network. Okay. Now for the actual deployment, we need to specify the tag that we want to use. I believe the default tag is just latest, and that is not going to use CUDA. It's not going to try and use your GPU. So I've specified here that it's going to use latest, specifically of the NVIDIA CUDA 12. And then we set runtime class. Now, from the live stream I did last week, that's where we get this value when you deploy the, what were they called, the NVIDIA device tools and the NVIDIA GPU operator. That is what is giving you this NVIDIA runtime in alongside container D. Again, check last week's stream for more about that. But we specify that we want the NVIDIA runtime class so that our container will have what it needs to run on GPUs. Further, we are going to specify that we want a GPU on this container. We only need one for right now. We only have one, the Tesla T4. Now there are some persistence, what are they called? Persistent volume claims that are in by default, and I just increased the amount of storage. There's a place for storing models, and there's a place for storing output. I assume this is images that it's outputting. I don't know that it's actually storing the text that it outputs, but storing the models, these can actually be pretty big, and depending on how many you want to be using, I just decided to give it 256 gigabytes, and anyway, scale that to your needs. Now, the tolerations is what I think I mentioned this a bit last week, but on the actual node in the Kubernetes cluster that has the GPU attached to it, we need to specify that we don't want a lot of other services running on that node, taking up the space for the ones that would need the GPU. So like something like Nextcloud or Gitea, which are not using a GPU, those should run on a different node in the cluster so that when I want to run something with the GPU-enabled node is available. And so I add a taint to that node. That taint key was special resources, and the value was GPU. Typically, the effect of this in Kubernetes, if I show you the actual, I'll make this a bit bigger. This command, what was the actual special resources GPU? I would set and then it's like, what's the effect is like no schedule, something like that. I think that may be slightly incorrect syntax. If you look up the kubectl taint syntax, you'll see exactly what it's supposed to be. Point being, I add that taint to the node that has the GPU attached, and then when I am deploying this service, I add a toleration that says that if we have a taint whose key is special resources and operator is equal to, and value is equal to GPU, then we are allowed to schedule on that node. It's a little bit confusing because it's saying the effect is no schedule, but I guess the way to look at this is that it affects the no schedule policy, and so if the no schedule policy exists or is true, it sets it to false, if that makes sense. I'm not sure if that's actually correct, but just trying to explain why setting the effect to no schedule in fact allows it to be scheduled. A bit odd, but anyway. Let's see this in action. If we go back to my terminal here, we can do we can see that the pod is running in Kubernetes right there, and I can access it on the web. Here we have. So I've downloaded a few models to begin with. Let me actually go ahead and take another timestamp here. And I don't want to press R this time so it doesn't stop my recording. Let's see. Okay. So this is LocalAI running on my local network. I have downloaded a few models to get things started. Some of them didn't actually work. If we go into models here and we look at this, whatever they call this, gallery, I think, the first ones that we see are Gemma 3. And I tried several versions of Gemma, and none of the LocalAI backends could run it. So at least straight out of the box as it comes from Kubernetes Helm chart deployed like this, not every model is going to work. So I am still testing models myself to see which ones I like and which ones work best. The ones I have at the moment, though, are Falcon 3, 3B Instruct, which is a large language model. I don't remember a lot of the details about where it comes from. I think there's some open source project behind it. Anyway, I don't know anything about this one, this voice one. I just downloaded it to test the talk system, but it didn't quite work out, so I haven't really done anything with this just yet. And then Whisper. Whisper I have tested. Whisper is OpenAI's, speech to text. So you give it an audio file of someone speaking, and it is going to give you back the text of that. Let's demo these. Let's take a look. If we go to chat, well, first of all, let's pull up my terminal, and let's do these things side by side. Because I want to show you here. On the terminal here, I am SSH'd into Alpha Worker 0, which is the node in my Kubernetes cluster that has my NVIDIA GPU, the Tesla T4, and I'm going to run this command NVIDIA SMI-L1. So every second it's going to update. This is not the prettiest way to see it. We can see it's a Tesla T4. Here's the temperature. It's running 28 watts out of a total of 70 watts. Here is our total VRAM, and what we want to see specifically is, unfortunately, it's this one. I might change the size of this a little bit more. Yes, if you pay attention to this right here, this percentage, this is telling you kind of the load on the system. We can see that there are two processes running on this. Llama CPP fallback, that is the back end for the language model, and then Whisper, which is the back end for Whisper. So when I send the language model something over here, we should see on the GPU this percentage increasing and our temperature increasing because it's going to be calculating things and doing things. So let's try and send it something. And this will also be a good speed test. So we'll get to see how fast our Tesla T4 is with a 3 billion parameter model. So let's ask it to write a Python script to tell if an array contains a Fibonacci sequence. We can see it's jumping up over there, 22% for a second. I'm a little bit nervous because it's doing something weird now. Previously, it was just spitting out, I set the model to Whisper up here. That's silly. Why would I send that to Whisper? Let's try that again. Write a Okay, before I send this, let's take note of what has happened here. We now have two Whisper processes running. That's probably not ideal, so I don't know exactly if that's going to die on its own or if I'm going to have to manually kill it. I don't know. We will see. But anyway, I'm going to go ahead and send this to Falcon, and let's try that again. It's very fast. We can see our process goes up to 88%. Our temperature has increased to 68 degrees Celsius, and we get a very fast answer. I'm not really bothered about testing this and seeing if it actually did a good job. Point being, it's fast and it works, and it's been deployed to Kubernetes. It's using a GPU that has also been available in Kubernetes, etc., etc. Cool. So, we can also demo Whisper. If we go over to here and then click on API, it's going to bring us over to here, and I'm going to keep the window I already have. Here we can see our audio transcriptions. So this is an API endpoint that's going to use Whisper to listen to an audio file and extract any spoken language as text. You can see I've already done it, but I'm going to do it again so that we can see that it too is quite fast. We might have a problem here because I deleted this file, I think. Hopefully not. Well, previously I got the response for what I recorded. Perhaps I should not have deleted that file before the live stream. Yeah, it's gone, unfortunately. Do I have a trash bin? This is Debian, so I think it just deletes things right out the gate, unfortunately. Okay, well, I don't have a audio file to demo. That's disappointing. But it can, we saw that it gave a response and that it was relatively speedy. You'll have to take my word for that part, I suppose, but it was accurate. We can see that. I literally recorded exactly what was written there, so nothing too exciting. But anyway, we can see that what we have here is a Whisper model that can extract pretty accurately text from audio, and then we also have a language model, and we are able to access this over an API. So what are we going to do with this? Let's take a timestamp and talk about that. Okay, so using the things here and the live stream that you see before you, I can do a few things to improve my content publication. I'm just going to get that out of the way. Let's make this full screen. And where do I want to go? Discourse. So far, with each of the live streams that I have done, I have made a post on Discourse. This is discourse.eom.dev. I host a follow-up discussion on each live stream. There has not been a lot of action over here, but that's okay because I'm just starting things out. Let's look at the last one. Scheduled GPUs on Kubernetes. If we go all the way up to the top, we see that there is the video. This is a link from minio.eom.dev, so my own instance of minio, and it just contains some chapters. These are the timestamps that I keep mentioning. YouTube actually picks these up and puts them in the video, which is really useful. But anyway, and I just have a list of topics. So I have a general roadmap for the stream before I start, and I just copy and paste all of this into a description. Same description ends up on YouTube. But with LocalAI, I can actually improve this procedure. So I can take even this video that I am recording right now, and I can strip out the audio, and I can give that to Whisper here, which is still failing to load my non-existent audio file, unfortunately. But I can give the audio file of my live stream to Whisper. Whisper can give me the transcript of the entire stream, and then I can give that transcript to LocalAI or Falcon and ask Falcon to write a better description for me. I can then have it, well, I can automate this pipeline using Gittee. So we have seen in previous streams, I believe this is when I was working on KrakenBot, which we may return to in the future. We have some Gittee actions. So I could, in theory, create an action that once I upload the video to MinIO, I can start the pipeline here. It's going to download the video, strip out the audio, get the transcript from Whisper, and then send the transcript to Falcon, and then get a new description, and then maybe it will email its new post description to my email address. I'm hosting an email server as well, so that stays in-house. And then I can decide whether or not to approve the new description, and then that description can end up on this. Now, Discourse actually works like a mailing list, and it does work both ways. So if that pipeline sends me an email with the post that it wants to make, then I can approve that post simply by forwarding the email to wherever it needs to go. I don't know how I have that set up just yet. But effectively, by hosting LocalAI in addition to all of the other services that I have here, I'm going to be able to tie them all together to create a automated content publication pipeline. I'll probably try that out with this very video. I don't have any of the automation set up for this, so it's going to end up being a lot of copy-paste and testing, but I think it would be pretty interesting to try. So if you go onto Discourse and look at the post that I will eventually make for this video, I will eventually follow up with the results of the transcript and the results of asking the language model for a description, and either this video or videos in the future, I'll start actually using the output of these language models and Whisper to actually generate the content of this platform. Okay. With that said, I want to point out the upcoming stream schedule. So I have been doing live streams Saturdays at 4 o'clock Eastern Standard Time. I don't want to pull up Owncast and show it to you because it might be really weird for me to pull up Owncast and show that on Owncast, so I'm not going to. But anyway, I have been hosting these on Saturdays at 4 and uploading them to YouTube the following day. And I am thinking, well, at least for this upcoming week, or excuse me, I'm thinking about too many things at once. For this upcoming week, I am going to do a stream on Tuesday that is going to be a reflection of the past 7 streams that I've done. I think I've done this for the past 7 weeks. So we're going to reflect on what has been accomplished in those weeks. And then the following Saturday, we will do a stream that is, I think it's on Saturday. Check Owncast for the schedule. We will do a stream that is planning the next quarter of the year of what we want to do on these this platform and on these streams for that. And then the new live streaming schedule for these demos is going to be Sundays at 11 a.m. Eastern Standard Time. I'll talk about that again more in the streams, and most people are watching this on YouTube anyway. So that's not necessarily a problem here. But anyway, we'll have a bit of a different week coming up, and then after that, I'll have a different schedule on a regular basis. Check Owncast to see that. I think that is all that we have for today. I've got a little bit of work to do fixing this video because the recording got cut off halfway, so have to try and stick them together, and then I'm going to try and do some stuff with some AI. So we'll see how this goes. But thank you very much for joining, and I will hopefully see you on Tuesday. Toodaloo.